of counter. Counter is nothing but a digital device which counts the numbers from 0 to n. N is equal to the number in binary. Depending on the number of flip-flops there are, it is used in the implementation. So if only one flip-flop is used, it is going to count from 0 to 1. Only two numbers it can count. If two flip-flops are used, 2 raised to 2, it is 4 numbers are possible. The minimum number is, it starts from 0, 0, goes up to 1, 1. 1, 1 means 3. So 0, 0 is 0, then it counts 0, 1, that is 1, then 1, 0, that is 2, then 1, 1, that is 3. If 3 flip-flops are there, it is going to count from 000 to 111. So in total 0 to 7, that is 8 different numbers are counted. 000 means 0, then it is going to count the next digit, that is 001, 1, then it becomes 010, 2, 3, 4, 5, 6, 7. So 0 to 7 means 8 different digits are possible for counting with using 3 flip-flops. And the flip-flops used in this arrangement are T flip-flop, that is toggle flip-flop. What is the toggle flip-flop? We have already studied. As the clock pulse arrives, and here we are using negative edge triggered clock. During the negative, for every negative edge trigger clock, we are going to have the toggling of the output. If it is 0, it becomes 1. If it is 1, it is 0. So every flip-flop output changes when the clock changes from 1 to 0, because it is negative edge triggered. Means when clock changes from 1 to 0, output toggles. When clock changes from 1 to 0, the corresponding output changes. So since the arrangement of the various flip-flops is, the output of one flip-flop becomes the clock of the next one. Output of the next one becomes the clock of its next. So the arrangement is in serial fashion. That is why this is also referred as serial counter or asynchronous counter. And the output is connected to clock of next, output is connected to, so it appears like a ripple. That's why it is also referred as ripple counter. So we are now going to see 3-bit ripple counter. Means it starts from 00 counting, goes up to 111, 000 to 111. Okay, so we are going to use 3 toggle flip-flops, and to the first flip-flop, negative edge trigger clock pulse is given, and during the negative edge of the clock, the output of the flip-flop changes, and this is connected to the clock of the next, and when the clock of this goes from high to low, that is negative edge, the output of this flip-flop changes. So this flip-flop is referred as FF0, this is FF1, this is FF2. So each of the flip-flop is T flip-flop, toggle flip-flop. And let us start the analysis of its working. Let us assume the counter is initially reset. Reset means all the outputs Q0, Q1, Q2 are in 0, 0, 0 state. This is 0, this is 0, this is 0 at the reset position. When first clock pulse arrives, then what is going to happen? The flip-flop zeros output, that is Q0, toggles during the negative edge of the clock. When this clock goes in the negative edge, when the negative edge of the clock arrives, this toggles. Initially it was 0, now it becomes 1. So the state of the counter after first clock pulse is, this has become 1, these are still 0 and 0. So 100 is the state of the flip-flop, state of the counter. Okay, counter consists of set of flip-flops. It is going to become 100. Now, next we are going to consider the second clock pulse negative edge arrives. At the negative going edge of the second clock pulse, again this F0 changes. Just now it had become 1, it becomes 0. So it has changed from 1 to 0. At the second clock pulse, the Q0 changes from 1 to 0. That is, it changes from high to low. So when this changes from high to low, this is the negative edge which is the connected to the clock of the second flip-flop, that is FF1. So during the this negative edge of the clock, the output Q1 toggles. Earlier it was 0, now it becomes 1. So as this becomes 1 to 0, this becomes 0 to 1. So during the second clock pulse negative edge, this goes 0, this becomes high. So the output is after the second clock pulse, Q0 has moved from 1 to 0, and 1 to 0 is negative edge. It is the clock of the second, so it toggles. Only during the negative edge of the clock, the flip-flop output toggles. Since the clock is 1 to 0, this toggles. Earlier it was 0, it has become 1. This process of toggling continues. The toggling is going to happen during the negative edge of the clock, and clock is connected to the output of the previous flip-flop. So this process of toggling continues till it reaches 111. And for subsequent clock pulse, after reaching 111, if next clock pulse is given, then it again starts from 00, again goes up to 111. So this continues, and it can count only up to highest 7. That's why it is referred as it can go from 0 to 7, means it is going to count total 8 digits. So that is why it is referred as mod 8 counter. So first, during no clock pulse, all of the outputs of flip-flops are at 0 state. After first clock pulse, this toggles. First flip-flop toggles. It goes from 0 to 1, and the others will remain at 0. The second clock pulse, this again toggles. This every time during every clock pulse, it toggles. It toggles from 1 to 0. This is high to low, means it is the clock of the next flip-flop. So during the negative edge of the clock pulse 1 to 0, this changes. Earlier it was 0, it is 1, it becomes 1. And here now Q1 is changing from 0 to 1. It is not the negative edge, so this remains in the same state. So after the next clock pulse, third clock pulse, it goes from 0 to 1. 0 to 1 is not a negative edge. Okay, so that's why this state continues. And since this state continues, there is no change here also. Okay, only if it changes from 1 to 0, this changes. So in this way, when Q0 changes from 1 to 0, this toggles. When it changes from 0 to 1, it remains in the same state. So when Q0 changes from 1 to 0, only then the toggling happens at Q1. Similarly, when Q1 changes from 1 to 0, Q2 is going to toggle. So this is going to continue, but the problem of this is it is serial, because output of first flip-flop is connected to the input clock of the next one. So this serial counter is asynchronous in nature. Since they are in serial, they are slow. Each flip-flops can change state only if the preceding, that is previous flip-flops have changed their state. This results in more propagation delay. of each flip-flop and causes the problem. That's why this counter is slow. But in synchronous, means parallel counter, clock pulse is applied to all flip-flops simultaneously. Here clock is applied, output of previous is input of in clock of next one. So it is slow. But if simultaneously all clocks are connected, it is considered as a synchronous counter, and it is going to reduce the propagation delay. Only one delay of the propagation delay of one flip-flop is going into sufficient to count from 0 to 7. And we are going to see such synchronous flip-flop in our next discussion.